we are, luckily, it was kind of a built-in review day yesterday, so we're just going to sort of do a whole bunch of things at once, but it's all just review. And then we are today doing constructions. So I'm not going to bust out the mechanical construction tools, the compass and protractor. I'm going to show you how to do it on the computer, and then you're going to just do it on a computer. But we're finishing up this section of special relationships and triangles. Now, on Wednesday, we talked about the median. This is page 1, by the way. This is the first page of our notes. So we talked about the median on Wednesday. What is a median? It is a segment that connects a vertex of a triangle to the midpoint of the opposite side. And so it goes from a vertex to the midpoint. So the middle, the segment gets bisected. It gets cut into 2 equal pieces, and the median is right there. So we have the median, which connects the vertex to the midpoint of the opposite side. Now, we also talked about the centroid. The centroid was the point at which 3 medians intersect in a triangle. So M is called the centroid, and you can see the markings on here. We have midpoints, because I can see my segment is bisected. And what does this do when we have this centroid point? It was something special about the centroid. Well, let's see. We got a bunch of congruent sides. So, for instance, if this side is 5, what's this segment here?
5.
Also 5. Okay. Because they're midpoints. If this side is 4, what's this side?
4.
4. Okay, great. Now, but we also had some special relationships within the medians themselves. So we had like this whole median right here gets segmented in a very particular way.
Oh, the 1, 2,
3. The 1, 2, 3. Yeah, the 1, 2, 3 relationship. We've got a small part, the bigger piece, and the whole thing. All right, the 1, 2, 3. That says 1, 2, 3. That looks terrible. 1, 2, 3. Okay. So, for instance, if I know the small part is 3, what's the bigger section? 6. And the whole thing is 9. 3, 6, 9. 1, 2, 3 ratio.
Or if you have the small part.
Yeah, if we have the small part and we want the whole entire thing, we just multiply it by 3. And so 3 times 3 is also the total of 9. Okay, so that is that 1, 2, 3 ratio we talked about, which turned out to be super easy as well. So today we are talking about the last 2 things, altitude and the orthocenter. So at the end, we'll come back and fill these in as well. So we're going to turn to this page, 5.5. The very last thing, which doesn't have anything very special about it, it is just a special word. I don't know. All right. An altitude is a segment joining a vertex. I totally spelled that wrong. V-E-R-T-E-X. A vertex. I have no idea what I started to spell there. A vertex of a triangle to the opposite side, so that it is perpendicular. Perpendicular to that side. So an altitude, and we're going to get very good at altitudes. We're going to use them all the time next semester. So altitudes come from a vertex and they drop down perpendicular to the opposite side. Very, very important. Now, it turns out that altitudes can be inside, outside, or on the side of a triangle. So if I go from this top vertex here, I'm going to drop an altitude straight down, so it'll be perpendicular. That altitude happens to fall inside that triangle. But here, I can see I have sort of an obtuse triangle. So that altitude, if I drop it down, it sort of doesn't hit anything. So what we do is just extend that opposite side. We extend the opposite side of our triangle. And now we can drop our altitude, and it turns out we drop it down perpendicular, and it falls outside that triangle. And sometimes we have a right triangle, and the altitude happens to be the side of the triangle. And so it just sort of depends on the shape of your triangle how that altitude happens to look, okay? Now, when we have 3 altitudes of a triangle, they intersect at the point called the orthocenter. Orthocenter. It's kind of a weird, yeah, I don't know anything special about it either. So what are the altitudes? BF is an altitude. It goes from a vertex and it's perpendicular to the other side. AE is another altitude, and CD is another altitude. Okay, what's the orthocenter? P, yes, the intersection of the 3. So you'll notice the difference here. These are perpendicular from a vertex, which is not the same as what we started with, which were perpendicular bisectors. So we have to be a little bit careful. And again, it's really about paying attention today because we are mixing them all up today. And so, as a little review, the circumcenter is created by the intersection of 3? No. Circumcenter. You go back to your front page. Perpendicular.
There we go. Next one's angle
bisectors. Yes. Perpendicular bisectors of each side. The incenter is created by the intersection of 3 angle bisectors. The centroid is created by the intersection of 3 medians. All right, and the orthocenter is created by the intersection of 3 altitudes. Okay, so, and this is the important stuff. A blank is equidistant from the vertices of a triangle. That would be the circumcenter. And the blank is equidistant from the sides. And there's a clue there. And incenter. And incenter is equidistant from the sides of a triangle. So let's turn the page. We're going to do a quick review here. Name that triangle center based on the markings. Classify each center as circumcenter, incenter, centroid, or orthocenter. What is in the picture here?
Angle bisectors.
Angle bisectors. If we have 3 angle bisectors, that means it's incenter. Very good. Again, write down what we're looking at. We're looking at angle bisectors. That gives us an incenter. Number 2, what did they give us?
Perpendicular bisectors.
No. Perpendicular, yes. Not bisectors. Why not bisectors? There's no congruence markings. Okay? These are, what are these? They're just perpendicular. What's that called? Altitude. Yeah, these are altitudes. 3 altitudes. They are from a vertex perpendicular to the opposite side, and that is the orthocenter. I wonder if that has anything, like, how do I relate that to, like, orthodontia? I don't know. Maybe we want our teeth to be straight, like perpendicular? I don't know. Okay. What am I looking at in this picture? No. What is this thing? It goes from a vertex to the, is it perpendicular? No. It is creating two congruent pieces. So this point is a midpoint. Medians. 3 medians, ladies and gentlemen. You have to look carefully at the markings here. This is 3 medians, and 3 medians gives me the centroid. Okay. All right, what do we have in this picture? Yes, we have perpendicular, we have bisectors. We have 3 perpendicular bisectors. What do we get when we have 3 perpendicular bisectors? Circumcenter. Circumcenter, 3 perpendicular bisectors. Okay. Number 5. Ooh, this is interesting. Well, in-center is created by angle bisectors. In this picture, they didn't tell me that my angles have been bisected. Instead, they're telling me that these 3 spokes are all the same length from this point to the vertice are all the same length. That's like a wheel. And so those are the spokes of a wheel. No. Circumcenter. Circumcenter, that circle surrounds the triangle, all right? It circumscribes, goes around the outside of the triangle. All right, over here, centroid. How do you know it's centroid? It's just like number 3. This is 3 medians. 3 medians are going from a vertex to the midpoint of the opposite side. So this is also centroid. So number 7. Number 7. No. In center. Once again, they're telling us that we have 3 segments that are congruent, like the spokes of a wheel, and this wheel is on the inside of our triangle. That is in center, an inscribed circle. All right, in center. Number 8 is orthocenter. We have 3 altitudes, so that's orthocenter. Number 9, in center. Why? 3 angle bisectors. All right, that's in center. And then circumcenter is correct. What did they give us here? A perpendicular. So here's our perpendicular bisectors that they're giving us. So 3 perpendicular bisectors. Yep, so this is circumcenter. All right, half of your test is just identifying these things, okay? That's half of your test, okay? All right, let's go back to the very first page really fast and complete these. A segment that connects a vertex of a triangle to the opposite side so that it is perpendicular to that side. So it drops down perpendicular to the third side is an altitude. And the orthocenter at the very bottom, the point at which 3 altitudes intersect in a triangle. So this is point M where we have the intersection of 3 altitudes. Nothing special about that. Okay, there's this review page, but I don't, we should do it or no, we don't need to do it, I don't think, but You can do that. So what we're going to do now is you have the instructions for how to do all the constructions, okay? We're going to use the construction directions here on Centroid and Orthocenter. That's all we can do in Delta Math. So have these handy, and I'm going to show you on Delta Math how to do the first few problems in Delta Math today.